Hi, I'm going to show you how to use AWK, and this is part of the course NAISS Intermediate Bash, and I'm going to walk you through the session about AWK. In this session we'll be using AWK, we'll practice a book using AWK, we'll use it in pipes. If you're going to read a specific column, that's what AWK can do. It helps you to select, for example, comma separated data or space separated data like tables. We're going to transform text, so that means we're going to add some extra stuff to it. We're going to combine AWK with regular expressions that we've discussed in a previous session. And we're going to practice reading bash commands. So we are in a course about intermediate bash use. I'm going to practice how to read bash commands that may look a bit more complex. So AWK is important because it is a programming language. It's made for text processing mostly, and it's included with Linux. It's a very old programming language. It's Turing complete. This means it can by definition solve any computational problems. So AWK has three different spelling, where the all uppercase is the name of the programming language. All lowercase is the program that runs AWK. It's the so-called AWK interpreter. And this is just a common misspelling about how to write down, I don't know, the name of the program or the programming language. It's used interchangeably. It's a misspelling. So let's take a look at the exercises. And taking a look at the exercise, we see 1, 2, 3 regular exercises. Then we have optional exercise 4. Let's start with exercise 1. Printing selected fields, and for this we need to read a chapter of a book we'll be using. The goal is that you can study AWK yourself if you enjoy this. If you want to know more, you have already been using a book. So the book is at the right, the exercise on the left. Read the text at chapter 6.2.1. So 6.2 printing selected fields. I just tick. Alright, so it's a bit, here is where it ends. Print command select data AWK reads a line divides an input separator. This is an AWK variable. The variables $1 hold the value of the second blub. 0 means the entire line. Alright, so the dfh command, whatever that does. So $1 is the first column and so on. In the output of ls-l there are 9 columns. Sure, we can believe this. The print statement uses these fields as follows. So here we have the command pipe to AWK and printing 5 and 9. And this is apparently how it looks like. The command print the 5th column of a long file listing which will need the file server and the last one the name of the file output is not very readable and uses official way of which to separate the money. It is the default output separator character. Usually space will be put in between each output field. Note that the configuration of the output of ls-l might be different on your system. Sure, I've read it. The single line of code in this subsection uses a pipe. Run the command until the pipe. So I have the command in my clipbox. I'm going to start a terminal. I'm going to run the command until the pipe. Let's see what we get. Because my screen, I have a big font, it's better for videos. I resize the screen. This is what ls-l shows. It shows the list of files that I have here. Good. Now I'll put it back to the right. You see that now it looks a bit more fluffy, but this is actually one line. How do you explain in English what this does? Well, I see the name of all my files and folders. I see if they can read or write or execute, if they're a folder or a file. I think who created it, who last changed it, is the file size, is it the last day or of modification. Those kind of things are there. So it shows in more detail information about my files. So we've done this, we indeed see this output. Like here we see total 4. Did I get that too as a first line? Scroll entirely up. Yeah, here. Apparently I have 116 files and folders. What does it do? Well, we can search the manual, man ls. I'm gonna look for the -L flag. Well, it's alphabetic, so it will be easy. KL here. Use a long listing format. Alright, so it lists the file, the directory contents in a long format. Sure, done. Now exercise 1.2, where we need to understand the awk part. The single line of code in this subsection forwards its output from ls to awk. Run it, what do you see? How do you explain in English what this does? Sure. Copy paste this text. Go to a terminal. Run it. So what it shows me is the 5th column and the 9th column. The 9th column is probably the name of the thing, and the 5th column is probably the file size. Unless it's a folder, then it's 4096 for some reason. But I know, for example, notes is a very small file. MyE is a very small file. I think it's 2 characters maybe. So it's like the size in characters, except when it's a folder. Show the 5th. Yeah, alright. So the answer is shows the 5th and 9th column. The command shows the 5th and 9th column of a list of file long format. How does awk deal with lines that do not have a 5th or 9th column? So let's go back to what we've seen here. We see an empty line here. This was this line with total. So if I just remove the awk command again and I scroll up, we see that the first line is total. That does not have a 5th nor 9th column. So then it just skips it. I'm going to go up again. Here we see this empty line. Awk shows an empty line. Good. Now this is an optional exercise, and we're going to pit awk versus cut. So we have been using cut in this course. How are we going to do the same thing? Try to use cut to achieve the same thing, because also cut can separate by selecting the same columns. Alright, so let's try this. So here we have the awk command, and now we're going to use cut. We're going to use like a field. It's called f 5,9 dash delimiter. That's a space. So this is what I get from using cut. And we see it already looks a bit different. I can get it better if I use 6 and 10. I know this because sometimes now I get suddenly a file name here, my documents folder. So why does this fail? Like it will not work. Observe and explain what you see. Well, it fails because there's a variable amount of spaces. If you take a look at the output we have gotten here, we see that, for example, here we have 2 spaces where this one only has 1. So that's the reason why cut does not work. You can use true for translate, but we're not going to do that. So that was exercise 1. Now we're going to start using exercise 2, printing selected fields. And for this I'm going to copy this link address here because we need to read a text. Let's take a look how long this text is. 6.2.2. It goes until all the way until here. Let's take a look. Formatting fields. Without formatting, using only output subject, I would look rather poor. Instead of answering a couple of tabs and string, this will make it a lot better. So here we see command, and we see this. We see this is a complex thing, and here we have the awk thing, and here it starts putting English stuff in it. Note the use of the backslash, which makes long input continue the next line without a shell interpreting as a separate command. Yeah, so this is this backslash. While the command line input can virtually be unlimited length, your monitor is not, and printed paper certainly isn't. Using the backslash allows for copying and pasting of the above lines into a terminal window. The .h in ls, so that's this. Here we see an h among the 3 letters too, is used for human readable. Sure. The output of long listing displays the total amount of blocks and directives given and the directives the argument. This line is used to, so we add an asterisk. We also add the so the asterisk helps you to not show the folders or the directories. They also add -d to get rid of directories too. Good. The backslash in this example mark the continuation of a line. Where are the backslash? The continuation of a line. I guess it's like in the, I guess it's below. Here. You can take out any number of columns and even reverse the order. In this example below, it's demonstrated for showing the most critical partitions. They have pipe it to some kind of sorting, then taking the first lines or excluding some lines. And here we partition. Here we show some text about the partition. And it's about this \t, which is a tab character, where the \n is a new line character, and \a is a bell character, which is not always supported. Good. I've read this. Let's understand the first part. The first code example in this subsection uses multiple pipes. Run the command until the first pipe. So this is like the whole command. I'm going to go to a terminal. I just pasted it here so I have it. I'll find later what it does. Oh, it's like a multi-line. Can I actually run it? Yeah, no. There. Need to get rid of this separator. And now it seems like a proper line. Yeah, so this can run. And now I'm going to only run the first part. There, star. What do we see? What do we make it a bit bigger? So now we see still folders. We see that suddenly it's not the amount of bytes, it's like a kilobyte or probably, well, these are small things anyway, so it's in bytes most of the time. Yeah, it's formatted a bit differently, sure. Good. How do you explain in English what this does? Use the LS manual. Well, we already read what these options did here, so I'm going to skip that. Understanding the second part. Run the command until the second pipe. Let's do that. So I have the full command here. I'm going to run this. Make it in full, so this is how it looks like without. And now I'm going to remove without this. Let's see if there's any difference. So I see that there's exactly no difference. So the reason we don't see a difference is because the second pipe says remove total from the text you're going to show now. It's called a grep inverted match on the word total. So all lines that do not have the text, that have the text total, will not match. This means all other lines are shown. Well, like this thing never shows me total at all, anywhere. Let's take a look. There's no total here. When I did ls it did, or ls dot, what was the other one? Long format. Then if I go up I see a total amount. But for this version, with -ldh, it doesn't show it anymore. So that means for me it's complete, the second part is useless. So this second part, removing the line with total, is not useful for me, so I'm going to skip it. Now understand the awk part. So now I'm going to run the full command. There it is. And let's take a look. Size is turned up, so it shows like how big things are. We need to tell something about this. Run the command full. What do you see? Well, I see how big all my things is. I like that it's more text. Size is the dip for file name. So that is nice. Yeah, it looks reasonably pretty. Exercise 2.4. Understand the single quote. First thing to notice is that the all command is put into single quote instead of a double quote. Why is that? So indeed here is a single quote, and here you see where my cursor is here. Here's a single quote, and there is a single quote. Why is that? Well, the reason is, let's just replace it by a double quote here. Like, weird things start happening, because now there is some interference from bash into this string, and using a single quote reduces that. For example, bash in $5 it will fill in a number, and apparently it already looked for a size. I have no idea what it exactly was trying to do here, but we need the single quote to make bash keep its hand off it. Exercise 2.5. Using commas between elements to print. Zooming in on the printing of org, that's the part blah blah, we can see the elements to print are separated by a space. Okay, let's take a look. Oh yeah, there's no comma here, for example. Okay. Yeah, this is uncommon, because mostly nowadays, because usually we would put a comma like here, and here, and here. We write the expression to use a comma between the elements, sure. So let's run this. Now I do see two spaces here. So I just need to remove the spaces that were added for me here. And now it's clean. So I had to remove the spaces that were here and then just use a comma. Good, so that rounds off exercise 2. Now it's time to start with exercise 3, where we're going to read this chapter of a book. This is the book, and it's called The Print Command and Regular Expressions. Alright, the regular expression can be used as a pattern by enclosing it in slash regular expression and test. Alright, so you put it like in between slashes like this. So for things that match this line of text, then let's show it. Okay, good. Slashes need not to be escaped because they have a special meaning to the awk program. So this slash does not need, like this first one, does not need to be escaped. This one apparently does, because it's part of the search string. Like for part of the regular expression, it should be def/hd, and to indicate it's a real slash, as in we're looking for a slash, you need to do escape that one. Below another example where we search the etc folder for files ending in conf and starting with either a or x using extended regular expressions. So awk, search for this thing. There's some kind of regular expression there, and then for each match print 9. Okay, so you can use regular expressions, good. The first code in the subsection uses a pipe. So that's this thing. And I guess I need to only run the first part. So let's do this. So I first paste the full command. And then I'm gonna only run the first part. There. Good. So when I do def h, it shows how much space I have. I get on my file per file system. I don't know exactly what these file systems means, but it shows how big they are, how much used, how much is available, how much I use. I can understand this to some extent. Use the df manual, right? If we need to use the df manual, man df. Report file system space usage. Great, I could have told you that. I already saw it. This -h, take a look what the manuals. I guess it's human readable. Yeah, it's human readable. There. Good, so this is, it shows in human readable format how much I use. Understanding the awk part. Run the command in full. What do you see? Well, I already ran the command in full and I saw nothing. Probably because nothing matched for dev/hd, and that's correct. So I'm gonna remove this hd part to get only the lines with dev in it. So I have a dev here. I guess that is shown then. But then it shows only 6 and 5. So this is 1, 2, 3, 4, 5, and 6. So it only shows the last two columns. 6 and 5. 1, 2, 3, 4, 5, and 6. So print 6. So boost AV. That's this one. Yeah, this has like dev in it. So this should be shown. This thing also should be shown. And then print 6 and 5. 1, 2, 3, 4, 5, 6. So this is this line. Then the boot dev sh. Alright, so this is more or less what it does. Dev shum, where's that? Dev shum here. Yeah, this has a dev in it too. That's this line, 1%. And then this boot AV, this is here. This has a dev here. Yep, good. So it shows now all the lines that match with the pattern dev, and then the 6th and 5th column separated by a tab. Good. Let's go back to the exercise. Sure. Understanding the regular expression. The awk command uses a regular expression. What is it exactly? What is it? If it is formatted weirdly, why is that? So they refer to this part. So it is the part between braces. I'll just zoom it in on my terminal here. So this exactly is the regular expression, the stuff between these regular slashes. And it's looking for the pattern dev/hd. And because this slash is also used in this context to mark the beginning and end, you need to add a backslash to escape it, to say no, this really is a slash. I'm looking for a slash here. This is not the end of the regular expression. So that is why you need that weird slash. Weird slash, it makes sense if you know why. Understanding the \t. So the \t is a tab. We've seen this in the book. Where was it? Here, it's a tab, we know this. So this means I have just showed you exercise 3. Hi, I'm going to show you how to do exercise 4, which is titled Can awk do and then something? Well, awk is a Turing complete language, hence in the apply to text this answer is always true. Below are some questions you may have and how to solve this in awk. Pick the topics you are interested in. Well, can awk display all columns? Yes. You can take a look at the book. The answer is to use $0 to show the full line. It was at the start. Can awk display the line numbers? Yes, it uses the special character called NR, which is record number, the number of records, and it increases per line. So line 1 has record number 1. Can it display the number of columns? Of course it can. You have to print NF. So note that this one has not a dollar, this doesn't have a dollar, but $0 has a dollar. If we want to display the last content, we do need to use $NF. So NF is the number of columns, or the number of fields, as awk calls it. Whereas $NF means show. So NF, it fills in the amount of columns, let's say 6, and then it prints $6, so which is always the last column, because per line it checks how many columns there are, so NF is updated every line, and with $NF say print exactly that last column. Can awk count the numbers of lines? Yeah, of course, we've just seen that using NR works fine. The problem is it will increase per line. You'll see you see it counting upwards. If you know the AND clause, that means this is code that's only ran at the end. If you dare print NR, the number of records or the number of rows, you see how many lines it has. And sure, this is not very impressive. This is what WC can do for word counting. You can add like some fluff around it. That is something awk can do uniquely. Can awk work on comma separated files? Absolutely. There are two ways to do this. So this is some example code. I don't care much about this for now. You can have a begin clause where you say that the file separator, the field separator, so the column separator, is a comma. But you can also call awk with this flag field separator and then put a comma there and then do the same exact code, but the begin clause you now moved to the command line call. Well, we've already seen the word begin now. So can awk show something once at the start? Yeah, you use begin. We can read this chapter. We're not going to do it now. Here we see that some text is being printed at the start. Can it show something at the end? Absolutely, it uses end. There, and done. Can awk use variables? Yes, of course, it's a Turing complete language. Let's say here we have an expression that sums things. So at the begin clause, it creates a variable called sum, sets it to 0. Then every line it adds what is in the 5th column, whatever that is. And in the end it shows the total sum. It depends a bit what's in the 5th column, what it does, but this is how it sums. So with this I have just shown you exercise 4. Now I'll be showing you some extra questions that may help you get better at awk and understanding awk a bit deeper. What is the difference between awk and awk? So awk with capital, only capital letters, and awk with only small case. Well, awk is the name of the language, and this is the name of the program that can interpret that language. What can awk not do? So if it's a Turing complete language, it means it can do all calculations, but maybe it needs a very long time and maybe a lot of memory and a lot of storage. So it cannot run computations at any speed. So it still can take billions of years. And you cannot rewrite it to use any small amount of memory. These are like all Turing complete programming language, like nearly all programming languages. They cannot do these things. We sometimes really need time and storage space to solve problems. When not to use awk, so this is a harder question. It depends, and there are multiple answers here. You could say, well, if you can use a simpler tool, do it. But I would say that awk shines at problems of intermediate complexity. For simple problems, tools such as grab, cut, and word count are just as good. You don't always need to use awk. You can, if you're a big fan of it, you can absolutely ignore these 3 commands if you want to use awk always. You can get away with that. However, when the problems get harder and it's no longer a one-liner, consider using a modern programming language instead. Also because those modern programming languages, they have libraries and packages that can, for example, read or analyze an entire table at once. And so awk has no assumptions on what it's reading or writing. It doesn't know it's a table or whatever. It assumes it's table in some way, but programming languages, modern ones, can do much better. Now it's time to talk about the conclusions. So awk, we have seen it can be used in pipes, and we've used this command here. It can be used to read a specific column using $5, for example. It can be used to transform text, that means adding some text, for example, adding the text size is. It can use regular expressions, for example, searching for the text def/hd. And it can do a lot more because it's a programming language. So when you want to learn awk, like there are like 4 books. There are 2 books, free and online, about awk. There are 2 books that have a chapter about awk. It's about Bash and Advanced Bash. That's exactly what this course is about. And there are 2 courses here about awk that me and my colleague, we have 2 separate courses, we sometimes give those. With this, I've just shown you, worked you through the exercises of awk as part of the course Intermediate Bash and Linux. And I wish you a very good day. Bye!